Good morning. Today we will be doing lesson 18. We will be brushing up on our skills regarding how to find an average of a group of numbers, as well as remembering how to read line graphs. Very quickly, let's review. An average is used when we want to take some groups of something, in this case it's pictures of books, and put them into equal piles. So, in other words, in this little diagram, we have 3 groups of books, and each group is a different size. There's a different number of books in each stack. When we find the average, we find out how many would go into each of these 3 stacks if we took the same number of books but spread them out equally. Well, we can do that by actually using little books and stacking them and working out a model. We can do that by drawing pictures. However, drawing pictures and actually using models is going to get to be a little bit cumbersome, and so we have now learned, or will learn, the mathematical way of figuring an average. Remember that when we find an average, we are simply making equal groups. As we turn and look at page 84, our problem says, in 4 classrooms there were 28 students, 27 students, I'm going to guess that is 9 students, 26 students, excuse me, and 31. So we see that we have 4 classrooms. They each have a different number of students. Our question asks us, what was the average number of students in each classroom? Well, to find an average, we follow a few steps. Number 1, find the total. And number 2, divide into equal groups. In the case of this problem, we will find the total by adding 28 plus 27 plus 26 plus 31. And we see that the total number of students is 112. Now, to determine how to divide into equal groups, again, refer back to your problem. In this case, we are told there are 4 classrooms. So when we're trying to determine the average, in other words, how many students would be in each classroom if they had the same number of students in each class, we need to divide our total by 4. And we come up with 4 goes into 11 2 times without going over. We multiply, we subtract, and we bring down. We divide again. 4 goes into 32 8 times without going over. We multiply, 32. We subtract. There's no more to bring down. Our problem's finished. Therefore, the average number of students in each classroom is 28 students. And you can see that that is how the problem's been done too. Notice, even our book points out the steps. First, we find the total number of students. Then we found the number of students that would be in each group if the groups were equal. So first we find the total, then we divide. In example 2, we're asked what is the average of 3, 7, and 8. I'm going to get a new piece of scratch paper and we'll work on that very quickly. Actually, we're just going to follow along in the book. First, find the total. 3 plus 7 plus 8 is 18. Then divide. Let's divide by the number of pieces of data we have, which is 3. We'll take it and split 18 into 3 equal groups, and we see that 18 divided by 3 is 6, and therefore the average of 3, 7, and 8 is 6. Let's look at a slightly different problem now that does still involve the idea of averages. In this case, we're asked what number is halfway between 27 and 81. So we've got some number 27, we've got some number 81, and maybe this is along a number line, and we are being asked what number is exactly halfway in between. Well, the way we solve this is again by using averages. First of all, we'll find the total of 27 and 81. Then we will divide by 2 because we want to find the number in the middle. Let's solve the problem and see if when you see the answer it doesn't begin to make sense to you. 27 plus 81 equals 108. 108 divided by 2 is 54. And so therefore the number in the middle must be 54. If you actually had a number line in front of you, you could prove to yourself the number in the middle is 54. For example, you might start at each number and work your way in by one, in by one, in by one, in by one, until you got to the middle, until your fingers touched, and it would in fact be 54. Perhaps maybe one of the ways you can think about this is that we've got a bar here on a bar graph that's 27, and maybe a bar here on a bar graph that's 81, and maybe this bar graph is counting M&Ms. And we want to know what number is halfway in between these two, because that's how you and I are going to divide our M&Ms up. So, just like in finding an average or looking at another type of story problem, we add our total, 27 plus 81, we divide by 2, and the number that is halfway in between 27 and 81 is 54, and you and I would each get 54 M&Ms. What I'm trying to say is don't let the slightly different worded sort of question confuse you. This is still an average problem. Now, moving on to line graphs. Line graphs, again, are just another way of creating a picture out of a set of information or a set of data that we have. Again, line graphs in particular are often used to show both comparison, but in particular, how measurements change over a period of time. So you can see, again, our good elements of any graph includes a title. This is Margie's height. Our horizontal axis is called our x-axis. It is labeled by age in years. Therefore, we know we will be able to see Margie's height at age 8, 9, 10, 11, 12, and so on. Our y-axis is again also equally labeled and measured. This time our y-axis tells us her inches, from 44 to 48 to 52 to 56, and so on inches. Notice that in each case our labels along that particular axis are equally spaced. We go from 8 to 9 to 10 to 11. We're going up by ones. In this case, we're going from 44 to 48 to 52 to 56. We're going up by 4 inches each time. Now we are asked, during which year did Margie grow the most? By creating a line graph, which simply connects the new piece of data with the previous data, we can look along this graph for the place where the line most steeply goes up. And in this case, we see it happens in between her 10th and 11th years. So, During which year did Margie grow the most? Well, it was during the year that she was 10, in between 10 and 11. The best answer there is the year she was 10, because all of the space in here shows the time after she had actually turned 10 and before she had turned 11. This little section of the line shows the steepest increase that indicates the biggest growth. And now let's go ahead and turn the page and look at our lesson practice. I am going to have you do just some of these problems. I'd like you to do A, C, and D for me. And then I'd like you to go back and look at the example 4 line graph and answer F, G, and H.